Today we will talk about hypothesis testing. This will be the first part of many videos. We begin with data, a population parameter, and we recall that point estimates help us estimate data using a single number. On the other hand, we had interval estimates that help us estimate data using a range of values, an interval in this case. Oftentimes, the objective of an investigation might be to decide the validity of two contradictory claims as opposed to coming up with an estimate. Such situations are quite common. For example, suppose we want to check the validity about a claim that a company makes about the amount of sugar in a box of cereal that it is selling. Or we want to check the amount of fat content in a gallon of whole milk. Or we might be interested in testing the diameters of pipes that are manufactured at a particular factory. And finally, in the context of clinical trials, we might be interested in knowing the efficacy of a certain drug. To be able to answer a question, we first need to precisely state it. And we also need to decide what would constitute an acceptable answer. This leads us to our first important definition of this video, that is the hypothesis. This is a statement about a population parameter. There are two important hypotheses that we will work with in this setting. The first being the null hypothesis, which is often denoted by H0. This is a statement about the population parameter theta that we believe or assert to be true. The alternative hypothesis, this is denoted by HA or sometimes H1 in literature. This is a statement about theta that is complementary to H0. The goal of a hypothesis test is to use sample evidence to either fail to reject H0, that is the null hypothesis. In this case, we continue to believe in the plausibility of the null hypothesis, or we reject the null hypothesis in favor of the alternative hypothesis HA. We make a few important notes. The null value is denoted by theta 0. This is the number used to make the assertion about the actual value theta in the null hypothesis. We have three possibilities with regards to the null hypothesis given a null value. One of them involves an equality statement, and the other two involves inequality statements with regards to the null value. Finally, we gather evidence as sample data coming from a random sample, that is random variables x1, x2, x3 up to xn. These are independent and identically distributed random variables coming from the given population, and will denote the set E to be elements x1, x2, x3 up to xn. This is the sample data corresponding to the random sample capital X1 through xn. We next focus on finding and evaluating hypothesis tests. The goal is to look for a procedure to reject or fail to reject the null hypothesis using the evidence E. We begin with a motivating example of a courtroom situation where we have John who is facing prosecution, and the jury has to decide if John is innocent or not innocent based on the evidence that is presented. We denote the evidence by E equals x1, x2 up to xn, and we will set up the null hypothesis to be that John is innocent. In this setting, the jury might be interested in the probability that John is innocent given the observed evidence. If this probability is high, the jury acquits John. If the probability is low, the jury decides to convict him. As you can see, this probability statement is quite easy to interpret. However, it's very difficult to actually compute such a probability. Alternately, we could consider calculating the probability of observing the evidence E given that John is innocent. This is a different conditional probability. We are now conditioning on the event that John is innocent, which means now we look at the evidence that has been presented in the light of John being innocent. And if the probability of the evidence given John is innocent is large, it means that under the assumption that John is innocent, the observed evidence does not seem out of place. This would indicate that given the evidence, we must not reject the null hypothesis, which means probably John is truly innocent. On the other hand, if the probability of the evidence given the null hypothesis is small, then under the assumption of the null hypothesis being true, the observed evidence is unlikely. That means our assumption that H0 is true must be wrong. In this case, rejecting the null hypothesis is probably a good idea. We're now led to the question of how does one calculate the probability of E given H0? We could consider a naive approach, that is, construct a tree diagram where the first level consists of the null hypothesis and the alternative hypothesis. And we have a bunch of conditional probabilities here along the edges. And we can calculate E given H0 using this naive approach, that is a product of all the probabilities along the branch divided by the probability of H0. This results in the following product of probabilities. We note that for this calculation to even make sense, we would need a bunch of assumptions. For example, if the random variable was coming, if the sample was coming from a continuous distribution, each of these point probabilities would be 0. Now, even if we could calculate these probabilities, we notice that each of these n probabilities would be numbers between 0 and 1. And if n is large, the product of all of these numbers will be small, no matter what each of them are. We consider a more sophisticated approach to an hypothesis test. So the first step would be to find a test statistic. We call it Z, and it satisfies three properties. Z would have to discriminate effectively between the null hypothesis and the alternative hypothesis. This means that the values of Z when the null hypothesis is true must be quite different from those when the null hypothesis is not true. Secondly, the distribution of this test statistic should be known when the null hypothesis is true. And finally, the statistic z should be calculated from the sample data or the random sample that we use to acquire our evidence E. In the next step, we will take the evidence E given by sample data x1, x2 up to xn, and we're going to calculate the test statistic on the sample data E to get small z. Assumptions on the test statistic provide us with a distribution to calculate the probability that capital Z is going to be greater than small z. We denote this number by capital P called the p-value. The p-value is the probability that the test statistic Z takes a value larger than the statistic small z calculated from the sample data or the evidence under the assumption that the null hypothesis is true. We're going to talk a lot more about the p-value in later videos, but for now, we want to move to step 3 of our program. That is, we want to relate the probability of evidence given the null hypothesis being true to the p-value. So if the p-value is large, we would want to fail to reject the null hypothesis. And if the p-value is small, we would want to reject the null hypothesis. The advantage of using the p-value is that we no longer have to make assumptions to calculate our probability of evidence given h0 is true, because we have a distribution for the test statistic z. Also, since the computation of the p-value involves a single probability calculation, we don't run into the problem of multiplying a large number of probabilities to end up with a small number. So we briefly summarize a possible hypothesis test procedure. The first task would be to identify the population parameter of interest. We will then set up the hypothesis, that is, the null hypothesis and the alternative hypothesis. We then find a relevant test statistic with a known distribution when the null hypothesis is true. We will then calculate the p-value p, and finally we will use the p-value to make a decision. We either reject or fail to reject the null hypothesis. Finally, note that it is not just enough to have a decision on whether to reject or fail to reject the null hypothesis. We also need to analyze the probability of making testing errors. We will very precisely talk about aspects of hypothesis tests in subsequent videos. This video was a more subjective interpretation of what a hypothesis test is if I were to introduce the subject to somebody looking at it for the first time. I hope you found it helpful. Take care of yourselves, and I will see you around.